Hello everyone, welcome back to another discussion in dynamics. Today we will continue kinematics of rigid bodies. And I think I'm not wrong if I'm going to say that this is the last discussion in this chapter, I believe, yes? And today we will focus on roll without sleep, and I prepared a brief lecture review and two examples. Without further ado, let's dive straight into our discussion. So here is a lecture review I prepared. So please observe that we have a flat surface in here, and we have a body placed on that surface. And that body was given omega and alpha rotating in this way. And also we have a radius of curvature at point O. So basically, that radius of curvature R is just at this point, okay? That body could equally look in the following way. That radius could be, I don't know, here, for example, and the rest of the body could have an arbitrary shape. Something like that. Okay? The most important thing in here is that we know the radius of curvature at contact point O. And there is no slip. There's also no slip at that point. So, if there is no slip, can any of you tell me what is velocity of point O? 0, 0, 0, exactly. 0, 0, 0. Yeah, today's brief lecture review will be run by students. So now let's focus on point C. Can any of you tell me what is the velocity of point C? I can give you a little hint. The trajectory of point C at this time instant is following. It's horizontal, right? So vector VC will be, I don't know, vertical, horizontal, or it will have an arbitrary direction. It will be horizontal, exactly. This is VC. So that means that that vector-wise, it will be, or component-wise, it will be VC 0, 0. Right? Yeah. Okay, how about O? How about accelerations? And let's start with point O. What is the acceleration of point O? Anybody? Will it be 0, 0, 0? No. It will have only one component, right? So acceleration at point O will be vertical, horizontal, or it will have arbitrary direction. Which one of those? It will be vertical, exactly, yes. So acceleration of point O will be pointing in this direction. So no slip at point O means that 0 is here only, yes, but not here. Yeah, and if you solve that problem, you will obtain A0 equal to omega squared R0, just as a digression. How about C? Acceleration of point C. Can it be vertical? Can it be arbitrary? Or does it have to be horizontal? It has to be horizontal because our point C must follow that trajectory, which is a straight line in this case. Exactly, so it will be, so AC will be here. AC 0, 0. And if you would like to solve that problem, you will end up with AC being equal to alpha R 0, 0. Okay, guys, so these four vectors, these are the velocities and accelerations of these 2 points, C and O, where O is a contact point between the ground and C is a geometric center of that half circle. And these vectors are all true because the surface is flat. If the surface is curved, these four vectors will look a little bit different. Okay? However, it was covered yesterday in the lecture. So if you attended the lecture, you know how they would look like when the surface is curved. If you haven't attended the lecture yesterday, you must watch the video. Professor Zin recorded. Okay, I'm mistaken again. Yesterday there was no lecture. Yesterday the lecture was pre-recorded. Yes, I am sorry. You must watch the video. Yeah. Okay, guys. And regardless of what I said, are there any questions to my brief lecture review? I don't see any questions. Yeah. In case you have some question, you can have some question later. Yeah, you can ask it later. Yeah. Anyway, example number 1. Let's do it. As usually, please familiarize yourself with the problem statement before we start our solution. Okay, so what do we have in here? We have one body that rolls without slip. So we have no slip in here. No slip at point O. And we know that radius of curvature is 12 inches or 1 foot. Moreover, we know that omega and alpha of our body are following. So our omega is 2 radians per second, and I think it rotates in a negative fashion, while our alpha rotates in a positive fashion, and it is equal to 3 radians per second square. And they ask us to find acceleration of point O and acceleration of point A. Okay, I think that we can start our solution. Yeah. So let's solve for acceleration of point O. In order to do so, I would like to do acceleration analysis between certain pair of points. Maybe one of you would like to join the discussion and tell me which pairs of points you would choose in order to find acceleration of point O. Anybody? Okay, that's a great choice. Yeah, between C and O. Yeah, and Joey, you have chosen these points because we have like partial information about them. Yeah, you know that O, acceleration of O would be vertical, and C will be horizontal. Perfect. So AC is equal to AO plus alpha times RCO minus omega squared RCO. Okay, and we know that our AC will have only this component, AC 0, 0, and AO will have only this component, 0, AO 0. Yeah, we can even draw them in the board. Yeah, so AC will only have this component. And AO will have only this component. Plus alpha is given, alpha is 0, 0, 3 times this vector, and this vector is not on the board. Let's draw it. It will be orange, okay? So this is RCO. And I think that its components are 0, 1, 0. Yeah, 12 inches is 1 foot. Minus 2 squared, 0, 1, 0. Okay, if you run this determinant, you will obtain following vector: minus 3, 0, 0. And that means that in here we will have -3, and in here we will have A0, -4, and 0. Okay, so from the equation on the x component, we can have AC equal to -3 feet per second square. And also in here we know that AO is equal to 4 feet per second square. Nicole? Yes, can I ask you to close the door? Yeah, these sounds annoy me. Yeah, these people annoy me there. Yeah, thank you. Thank you, I appreciate it. Yeah, okay, so we have our answers magnitude-wise. Now let's write them vector-wise. So I think that AC vector-wise will be -300 feet per second square, and AO will be equal to 0.40 feet per second square. Okay, guys, I have nothing else to add. Any questions to about what happened on the board? Yeah, we found AO. Yeah, AO is here. Yeah, and just we also found another thing. Yeah, this is a byproduct of our solution. Byproduct. And this is the answer. Yes, Olivia? Ah, yeah, you're right. You're right, because I guessed it. I knew the answer before, yeah. Just because I know that there is no slip in here, and our alpha points this way. So I knew that we will end up with AC pointing this way. You are correct. You caught me. Okay, I surrender. Yeah. Yes, you got a mistake. Yes. Basically, you see that we have no slip in here, and I know that that body rotates that way. Yeah. So I know that AC will point this way. I will keep my eye on you from now on. Yeah. Okay, let's flip it. Let's flip it. There we go. Okay, now let's find acceleration of point A. And again, guys, please choose pair of points you would like me to use in order to solve that problem. AA is equal to question mark. So Axel analyzes between. Okay, which points do you want to go for? Anybody? C and A. Okay, so I'm going to run acceleration analysis between A and C. Yes, and at home, if you would like to. So at home, do exactly the same between A and O. Just for training, if you want to, of course. Yes, it's not required. Yeah. Anyway, if you run acceleration analysis between A and O, you should obtain exactly the same results we are going to obtain within 3 minutes. Okay. So, but we are going to focus on acceleration analysis between A and C. So I can write. So I can write AA, that is equal to AC plus alpha times RAC minus omega squared RAC. Okay, and AA is not known, but AC is known. AC is equal to -300. We just found it. plus 003 times this vector, and this vector is not here. I must draw it, yeah? So that vector will be green. This green vector, this is RAC. And I think that its components are half, minus half, 0. Yeah, 6 inches is half a feet. Minus 2 squared times exactly the same vector. Okay, guys, if you solve this determinant, you will end up with 1.5, 1.5, 0. And that means that our acceleration of point A is following. It's minus 3 plus 1.5 minus 2 and 1.5 plus 2, 0. Minus 3.5, 3.5, 0 feet per second square. This is the answer. Any questions? I don't see any questions. Are you sure, guys? Are we on the same page? Cool. Yeah, okay, so what now? Example number 2? Let's do it. So as usually, feel free to take some time and read and understand the problem statement before we start solving it. Okay, so what do we have in here? We have 3 bodies. We have, first of all, cylinder A that is fixed, right? Cylinder A does not move at all, which is good. Yeah, which is it simplifies the problem for us, because now we know that every single velocity, the velocity and acceleration of every single point that belongs to this cylinder is 0. We also have another cylinder. I refer to it as gear. So we have cylinder B, gear, that is rolling on top of the other cylinder, right? And it rolls without slip, as you can see. No slip between these 2 cylinders. And these 2 cylinders are also connected by link CD. And I think that the thing we know are those guys. We know omega CD and alpha CD. Yes, these are our knowns. And they ask us to find what is alpha gear. So this quantity. And once we have that alpha gear, they ask us to find acceleration of this point, of point E. Maybe I can mark it with blue. So they ask us to find acceleration of point E. Point E is a contact point between these 2 cylinders. I hope you can see it. Point E does not belong to the link. Do you see it? Point E is behind the link on that picture. Okay, just make it clear. Point E is a contact point between 2 cylinders. Okay, guys, so what shall we do? Shall we dive straight into acceleration analysis? and solve the problem? We could. However, I have one question to you. Do we know this value? Do we know this quantity? Omega gear. It's not given to us, yeah? And I think that we will need that in our acceleration analysis, yeah? So what shall we do first? You can say it louder. Analysis. Yes, thank you, Liz. Yeah, Liz is right. Before running acceleration analysis, we must run velocity analysis. So there is like implicit part 0, yes? So before part 1 and before part 2, we will do part 0, which is in which we will find omega gear. And we will do velocity analysis. Yeah, which makes that problem a little bit longer than you expected. Anyway, in order to find omega gear, I would like to express velocity of point D in two ways. Express Vd in two ways. First, I would like to run velocity analysis between D and C, and then I would like to run exactly the same, but between D and E. So in here, I can write Vd that is equal to Vc plus omega of certain body times R dc. And in here, I can write Vd that is equal to Ve plus omega of certain body times R dE. Okay, and now some of you already know what I will ask you for, yeah? I would like to ask one of you or two of you to help me in filling out these black boxes. What shall I put in these black squares? Yeah, in other words, omega of which body is this one? And of omega of which body is this one? Who would like to help me? Jaden. Yep. Yep. CD and gear. I cannot write. Oh, no. Okay. But you know, we are at university, so I must ask why. Can you explain it? Can you make sure that your sentence is, your answer is one sentence long? Why you choose omega CD in the first equation?
Based on the vector you cross.
Okay, so why did you? So why didn't you say DE in the second equation? Okay, I know why. Because this is the other one. Okay, I want to switch person I am collaborating with right now. Okay, who can explain me why Jaden has chosen omega CD in the first equation and omega D in the second equation? I need one sentence long answer. Nathan, do you want to do it, or you don't want to do it? If you don't want to say, I don't want to do it.
No.
Okay, no problem. Oh, come on, guys. Who will help us? Liz, do you want to say something, or you just want to chill?
Not exactly sure, I guess.
No, no worries. Yeah, you don't have to be. Yeah. I'm gonna use my secret weapon. I'm gonna use Sean. Or no, Jack? Yeah, go for it. No. Sean, can I use you?
Omega C causing velocity v relative to C, and then the omega gear is causing a component velocity relative to V.
more or less. However, I would not accept that answer. No, yeah. So I will give you an answer. Yeah, no worries. Yeah, yeah. So guys, the answer is following. We choose omega CD in here because in this equation we analyze the link. Yeah, we just analyze the motion of the link. Do you see that? We analyze this motion. We put omega gear in here because in the second equation we just analyze the motion of this cylinder. Okay? I will give you even better answer. We put omega CD in here. This is omega of the link, yes? Because points C and D, they belong to the link. Yeah, that's why we must use omega of the link in there. And we used omega gear in here because points D and E, so these points, D and E, they belong to the gear. So we are going to use omega of the gear. Do you see that? Yeah, okay. Really? Ah. Okay, so English is not my first language. I'm sorry, yeah. That's why we have a regretting period. If I make a mistake, you can always complain, yeah? This is what he said? No way. Charlie, this is what he said? No, 2 against 1, exactly. Okay, anyway, this is why these are those subscripts. And that was actually one of the most important part of this discussion, guys, yeah? So, you know, we can like have fun in here and laugh and smile, yeah, but please make sure that you understand why these subscripts are in there, okay? Please make sure about it, okay? Okay, so I think the art is done, and now we should start some labor, yeah? So now let's solve these two equations. So VD is not known, and VC. What can you tell me about velocity of point C? It is 0, and this is because point C is fixed. C is fixed. Okay, so in here I can write 0, 0 omega CD. Does it rotate in a positive fashion or a negative fashion? In a positive, so it can stay like that. And RDC is not on the board, so I must draw it. RDC, it will be this long vector, yeah? This long horizontal vector. So this orange one is RDC. And I think that its components are 2R, 0, 0. And if you guys solve this determinant, you will obtain following vector. 0, 2R, omega, CD, 0. Cool. Okay, now second velocity analysis. Let's take this equation. And again, I would like to ask you for help, guys. Can you tell me what is velocity of point E? Yes, but for a different reason, right? And it was Grace, it was you, right? Who said it? No, Olivia, it was you, yes? Yeah, why is it 0? Perfect. Yeah, it is 0, but for a different reason, exactly. E, no slip at E. Okay, so now let's also write down this determinant and let's solve it. So in here we will have 0, 0 omega gear, which is not known, but I assume that it rotates in the positive direction, times this vector that is again not on the board, so I must draw it. It will be green, this guy, RDE. Okay, so this guy will be R00, 0, and this determinant will be 0 R omega CD 0. Perfect. Okay, guys, so we expressed velocity of point D in 2 different ways, but it's still the velocity of the same point. So I can write down VD that is equal to VD. Yeah, this is trivial equation, but that means that this vector must be equal to this vector. Okay, so we ended up with 3 equations, yes? 2 out of them are trivial. 0 is equal to 0. And the only interesting thing is happening in the y component. So in here we can see that 2r omega CD is equal to r omega gear, yes? I made a mistake. Yeah, sorry, this subscript should be gear. Sorry for that. Oh. We can get rid of r's, and we can see that our omega gear is twice faster than omega CD. Omega gear is 2 omega CD. And vector-wise, omega gear is obviously 0, 0, 2 omega CD. Yep. Any questions? I don't see any. Yeah, so anyway, we are done with velocity analysis. So now we can start the actual problem. Yes, now we can start our acceleration analysis. So let's do it. Now, accel analysis. And I actually forgot what they asked us for. Do you mind if I scroll up the board? Aha, we must find these 2 guys. We must find these guys. And maybe picture will be useful. I'm going to copy the picture as well. Maybe a little bit larger, like that. It should be fine. Okay, so in order to solve for these 2 parameters, I would like to express acceleration of point D in 2 different ways. But before I do that, I see that there's one more question. Yes, Nicole. I see. Yeah, no problem. These vectors correspond to DD. DD points this way. Omega rotates. Yeah. Omega always points, in that case, towards you. Full answer? Yeah. Awesome. Yeah. Yeah, no worries. Anyway, in order to solve for these 2 guys, I want to express AD in 2 different ways. I'm going to use exactly the same 2 pairs of points. So I'm going to do D with respect to C and D with respect to E. So I'm going to write down AD that is equal to AC plus alpha of certain body times R DC minus omega of certain body times R DC. And in here, I will use exactly the same equation, but with different subscripts. So I just don't mind if you allow me to copy and paste it. So this will be this equation, but I will just change the subscripts. It will be E in here, and E in here. Okay, guys, I am not going to ask you what shall I put in those black boxes, because the answer is exactly the same as the previous one. Okay, just make sure I just wrote down these black boxes just to bring your attention that this is important, okay? So just make sure that you understand why link CD is here and why gear is here. Okay, so I think that's the art. We are done with the art, yeah? So now labor. Now we should do the labor and solve the problem. So let me start with the first equation. So I'm just going to take this one. And maybe one of you will again tell me what is the acceleration of point C. It is 0 because it's fixed. C is fixed. Okay, so now acceleration of point D is equal to 0, 0 alpha CD times RDC. And RDC is already on the board. It's an orange vector. So this will be 2R 0, 0 minus omega CD squared 2R 0, 0. Okay, so now let's solve this determinant. But actually we don't have to, you know. And this is the little trick I would like to sell you today. And with that little trick, you will save 1 or 2 minutes on your exam. So please observe that this determinant on at the bottom is exactly the same as this one. As this one, we run into our velocity analysis. So basically, I can just rewrite this vector in here. Do you see that? So in here, this will be 0, 2R alpha CD, 0. Okay? This will save some of your time on the exam. Just rewrite that vector and replace omega with alpha. Okay? Was that clear? I hope so, yeah. Anyway, yeah, this is like part of my job, yeah? My job is to help you in succeeding in this course. I think that this is part of it, yeah? Just sell you these little tricks to save you some time during the exam. Okay, so let's continue. So in here we will end up with minus 2R omega CD squared, and in here we'll have 2R alpha CD 0. Okay, I think that we cannot squeeze anything else from this first equation, so let's focus on the second one. Let's focus on this one. Okay, and now guys, please tell me, what is the acceleration of point E? In other words, I would like one of you to fill out these red brackets. Okay, just to remind you, point E is a contact point between these two cylindrical surfaces. Okay, and this surface is fixed. And point E is here. And there is no slip at point E. Can any of you tell me what direction will acceleration at point E have? Can it have such component? Yes, Nathan? It won't, because I know why you said it, yeah. This is not a flat surface. Do you see? In here we have a roll on the curved surface. So those equations I showed you during the brief lecture review, they don't apply here. Yeah, but anyway, we can deduce something else, yeah? So Nathan, please let me know, can our acceleration at point E, can it be vertical? Can it have vertical component? Or shall it be horizontal, or can it be arbitrary? It has to be horizontal, yes. So our acceleration at point E will be pointing this way. It is, of course, point E belonging to this cylinder. This is point E belonging to this cylinder. Okay, because only that cylinder can roll. The other one is stationary. Yep. So that means that our AE has following components. AE 0, 0. Because at this configuration, our AE points in a horizontal direction. So we can write AE 0, 0 in here, plus, I think alpha gear is not known, 0, 0 alpha gear. And this vector is a green vector in the top right corner. So this will be R0, 0 minus omega gear. Oh, omega gear we found in the velocity analysis. Do you see, guys? Let me scrub the board. Omega gear is here. We calculated it. It equals to 2 omega CD. 2 omega CD squared. R0, 0. So now you see why velocity analysis was needed and required before running acceleration analysis. Yes, we had to know, we must know this value. Yeah. Okay, let's solve this determinant. We actually already solved it earlier in this discussion. So it will be equal to 0 R alpha gear 0. Okay, and if you want to summarize everything, our AD will be actually equal to AE minus 4 omega CD squared R alpha gear 0. Okay, guys. So we found acceleration of point D in 2 different ways. And the rest of the discussion is very similar to what we did in our velocity analysis. We are just going to compare AD to AD. So I can just copy this vector. And I can paste it here. And this is equal to this one. Okay, so now if we look at the y components, we can see that our 2R alpha CD is equal to R alpha gear. And that means that our alpha gear is twice larger than alpha CD. And vector-wise, it's 2 alpha C D K. Now let's have a look at the y components, or what I'm talking about, x components. And in here we will find AE, which is equal to 2 omega CD squared R. And vector-wise, AE is equal to 2 omega CD squared R 0, 0. Yeah, exactly what Nathan observed earlier. Yeah, you can see it here. Oh, sorry, guys. I must make these ones shorter, smaller. And now I think that everything will fit in one screen. Yes. Yeah. So the direction of AE is this: 2 omega CD squared R I. Yeah, I think that's it, right? This is what they ask us for. Yeah, that was the question. And we found these two guys. Okay, so we found this one and this one. Any questions? Okay, so thank you for today. I will hang out like for 5 more minutes. Yeah, enjoy your weekend.